case, let's get started. So in year 10, the trig you work through is mostly just non-right angle trig. So one's where we don't have that right angle triangle, right?
Yeah.
Yeah, so you're used to working with triangles like this, right?
Yeah.
Yeah, but now we can work with any sort of triangle, so it can look something messy, it can be really tall, it could be really thin. Yeah, it doesn't matter. So we're trying to get more general things and stuff that works for every single triangle. That way we don't have to try and make them a right angle.
Yeah.
Yeah. But before we do that, we're just going to do a review of trig, and then we're going to get into some more interesting stuff.
Yeah.
Okay. Awesome. So do you remember how to put this into your calculator?
I'm just gonna get it. I think so.
Okay. So can I get you to try doing that first one for me? So sine 45 degrees, how would you put that into your calculator?
You would say and then 75.
Yep, and close bracket.
Yeah.
And then what does that equal to?
0.97.
Well, it's the three decimal places, so
0.966.
perfect, exactly right. So that's going to be 0.966, right?
Yeah.
And then how do we get this in here? So it's 65 degrees, tan, 65 degrees and 7 minutes. How would you get that in there?
You the 65 and then the degrees.
Yep.
And then 0.7 and then degrees and then close bracket.
Yep. And then what does that equal to?
2.156.
Perfect. That is exactly right. 2.156. Perfect. Does that make sense?
Yep.
So if theta is between 0 and 90 degrees, find theta correct to the nearest minute. So how would you do this one?
Would you go shift side?
Yeah, shift sine.
And then 0.5. You just close bracket.
Yep.
And 30. Or
Yeah.
30.
Yeah, so that's going to be 30 degrees and 0 minutes.
Yep.
Actually, I probably just have to put the 10. Does that make sense?
Yep.
And what about that next one?
So the shift, sorry.
Pardon?
0.8.
Oh, yep. Shift cos 0.
0.89.
Yep, close bracket.
Yeah.
And what does that equal to?
27. Oh,
So we wanted to the nearest minute, remember?
27 degrees and 8, 7. Is it 8 or 7?
8. And why is it 8?
Is it because it's 36 seconds?
Yeah, so it's 36 minutes, it's 36 seconds. And when we have minutes, we're rounding to 60, not to 100, right?
Yeah.
So 30 and above is going to round up because it's more than halfway there, right? Perfect. All right, so complete the trigonometric ratios for the following triangles. So can I get you to walk me through these ratios here?
So, yeah, so sine it equals to um, 4/5.
4/5, that is perfect. That is because sine theta equals to opposite over hypotenuse.
Yeah.
Cos theta equals to adjacent over hypotenuse.
Yeah.
And tan theta equals to opposite over adjacent, right?
Yeah.
All right. And what about this cos theta?
5, 3/5.
Perfect. And tan theta?
4/3.
Perfect. That is exactly right. Does that make sense?
Yeah.
Yeah. And what about find the value of the unknown side, x, correct to 1 decimal place? So how would you find x here?
Um, it, it's 10. Right?
It'll be shift tan, but we have to get a tan first, right?
Yeah.
So what'll it be? First step.
The um, the 68 is
So it'd be, sorry, I can't quite hear you.
it's uh,
10?
10 equals 10. Well, 10 x over
Not,
11.
yeah, so tan 68 degrees equals to, and what's that going to equal to?
Um, x over 11.9.
Yeah, 11.9. And then how do we find x?
Times 11.9. 1068.
Perfect. So x equals to 11 point, sorry, that should be there, 11 point, I'll just rub that out. 11.9 tan 68 degrees, right?
Yeah.
Does that make sense?
Yeah.
Yeah, and then you can just put that into your calculator and get a solution. So then with question 5, how would we do, what ratio would we use here?
Um, a sine.
Sine, yeah, so we'd have to use sine. And then, so what would we do here? So we'd have sine what?
Sine 39.
Equals?
6 over 8.
Yep. And then what's a going to be equal to?
And it is 6 divided by sine 39.
Sine 39, right? Perfect. Does that make sense?
Yeah.
All right. All right. Is all of that okay?
Yeah.
Yeah.